Greetings, I'm Deb the developer.
And I'm Glitch.
In our last video, we built an inheritance hierarchy, a base employee class with hourly employee and salaried employee derived from it. Today, we're going to fix a problem with that design. Right now, nothing stops someone from adding a new employee type and just forgetting to implement pay calculation. We'll look at 4 keywords that give you control over exactly how derived classes can customize behavior: virtual, override, abstract, and sealed. So let's start with the problem. In the last video, employee needed to have a CalculatePay method on it. And here's the thing about that method.
Right, we should put a body on it that just returns 0. Or actually, I think it should return -1 as a sentinel.
And what happens if someone on your team adds a new employee type, derives from employee, and doesn't bother implementing their own version?
Well, it just uses the base version, so it returns -1.
And that gets fed into payroll.
Oh, that is a bad payday for someone.
The worst part is there's no error, no warning, no complaint from the compiler. The program runs, produces wrong numbers, and you find out at the end of the month. So let's build towards something better. Let's start fresh with a simpler example because the concepts are easier to see before we complicate it with a full payroll system.
Okay, what are we building?
Animals. Glitch, create a new file, animal.cs.
On it.
Good. Now add a dog that derives from animal and give it a real sound. Okay, does that look right to you?
I mean, yeah, dog has a sound method that returns woof. So when you call sound on a dog, you get woof.
Try it. Create a dog, call sound, print the result.
Yeah, it prints woof, I was right.
Okay, now change the variable type. Don't change what you're assigning, just change var to animal.
Wait, like this. But that's still a dog. That's obviously still a dog. It should still say woof.
What does it say?
Nothing. It says nothing the animal version, but that's wrong. That is a dog. Why is it using animals version?
Because C# didn't know you wanted dog's version to replace animal's version. You just wrote a method with the same name. That's not the same thing as replacing it.
Wait, so having the same name isn't enough?
Not even close. What you wrote is called method hiding. The two sound methods just coexist as separate methods. When C# sees a variable declared as animal, it calls animal's version. It doesn't care that the object is actually a dog.
That is a very rude thing for C# to do.
The compiler actually warned you, by the way. Did you catch that?
There was a warning. I assumed it was just complaining about variable naming or something.
It was telling you that you were hiding a method and it was probably not intentional. And it was right.
Okay, so how do I make it actually replace the method?
2 steps. 1 on each side. On the base class, you mark the method virtual. That tells C# I am specifically allowing derived classes to replace this. And on the derived class, you write override. That tells C# I'm actually replacing it. Both sides have to declare their intent. One alone is not enough.
Okay, let me fix this. And the warning is gone, and now. Woof, oh, it's using dog-s version even though the variable is typed as animal. Because we told C# that dog-s method is a proper replacement, not just some other method with the same name.
Right. Virtual opens a door. Override walks through it. You need both.
That's actually a clean way to think about it.
Now, let's add a cat and a fish. What happens when you call sound on a fish?
Fish doesn't override it, so it falls back to the base version. Gets the nothing, which is honest, really. Fish are quiet.
That's the key behavior of virtual. Overriding is optional. If a derived class doesn't override, it just uses the base version. No error, no problem. Virtual says you may, not you must.
Wait, so what if you need a you must, like with CalculatePay?
That's exactly where we're going. Let's bring the employee hierarchy back.
Okay, should I start with employee?
Yes, but before you type anything, does it make sense to create an employee object directly?
Sounds like calling new employee with a name. I mean, what would you even pay that person? We don't have a formula. There is no generic employee pay rate.
So should the base class be instantiable?
I want to say no, but I don't know how to stop it.
You declare it abstract. When a class is abstract, the compiler refuses to let you call new on it. It exists to be inherited from. That is its entire job.
So it is like a template for a category of things, a blueprint for things that pay employees somehow, but not an actual payable thing itself. It defines the required structure that everything underneath it has to fulfill.
Exactly. And the method that the derived classes are required to implement, you make it abstract too.
What does an abstract method look like?
Just a signature, no body at all, not even empty braces. The line ends with a semicolon.
That feels wrong, a method with no body.
It's intentional. The absence of a body is the point. It's saying this method exists, it has this shape, and you must fill in the body. It's a contract in the type system. C# enforces it at compile time. If you derive from an abstract class and don't implement every abstract method, your code does not compile.
So instead of a silent wrong value at runtime, you get a build error right away.
Before the program runs, before payroll processes, before anyone gets paid -1.
That is genuinely great. Let me write this.
Good. Now, employee can also have a virtual method, something that has a reasonable default, but that derived classes can customize, like a job title. So now we have a class with regular members, an abstract method, and a virtual method, all three in one place.
Wait, so the abstract class itself can have constructors, even though you can't do new employee?
Yes, because derived classes can still call the base constructor in their constructors. The abstract class can set up shared state that every derived class needs. It just can't be the thing you directly instantiate.
Okay, that makes sense. So the constructor exists for the benefit of derived classes.
Right. Now write hourly employee. Good. Now, before you write salaried employee, try something. Start a new class called part-timer that derives from employee. Give it a constructor and then just don't implement CalculatePay.
Oh, I see what you're doing. Okay. And Visual Studio is already unhappy. Let me try to build it. Error CS534, part-timer does not implement inherited abstract member employee.calculatePay. It won't even compile. That is exactly what we wanted.
That error is a feature. You get it the moment the code is wrong, not 6 months later when someone reads a pay stub.
I am deleting part-timer. It does not deserve to exist.
Fair. Write salaried employee instead, one that actually earns it. And let's go ahead and use these.
Rosa gets $18,000 for 80 hours at $22.50. Marcus gets $6,000 a month on a $72,000 salary. Those are actually real numbers now.
And if someone adds a new employee type and forgets CalculatePay, the compiler catches it, not the HR department.
Okay, so I want to make sure I have this straight. Abstract method means no body derived classes must implement it. Abstract class means you can't do new on it. You need both.
If a class has any abstract member, The class itself has to be declared abstract. The compiler requires it.
And a class that's abstract can still have regular methods and virtual methods mixed in.
Yes, you can have methods with full implementations, methods that are optional to override, and methods that are required to override, all in the same class.
That's actually a really expressive design space. You get to say exactly how much freedom derived classes have over each piece of behavior.
Which brings us to the last keyword. Let's say you have a manager derived from salaried employee. It gets a base salary bonus each month.
Okay, so manager extends salaried employee. I'll write it.
For CalculatePay, the manager gets their base salary calculation plus the bonus. And salaried employee already has a correct CalculatePay. So instead of duplicating that math, let's use it.
Oh right, I can call base.calculatePay and then add the bonus.
Good. Now you're the designer of the system. Someone on your team says, I want to write a regional manager that extends manager. Is that something you want to allow?
I mean, probably not. Manager is already a very specific class. It has a specific pay formula. I don't want someone building a whole chain off of it and breaking the payroll logic.
Then you seal it.
That's the sealed keyword.
Yes, seal the class and the compiler will refuse to let anyone inherit from it. Now, try writing a class that inherits from manager.
Cannot derive from sealed type manager. Immediate build error.
Sealed is a design statement. It means this is a complete final implementation. The inheritance chain stops here. It's not about hiding something or protecting it. It's about encoding the intent that this class is not meant to be extended.
So it's less of a security lock and more like a posted sign.
Exactly. And you can also use sealed on a method, not just a class. If you've overridden a virtual method and you want to stop further classes from overriding it, you put sealed on that specific override.
Wait, so a method can be sealed override?
Yes, those two keywords together. You're saying, I have overridden this method, and I am the last who will.
That is a very specific thing to want.
It's rare. Most of the time you're sealing the whole class rather than individual methods, but it exists for situations where the class itself can be inherited, but one particular method's behavior needs to be locked down.
Okay, so let me run through what I know. Virtual on a base class method means you may override this. Override on a derived class method means I am replacing this. Abstract method means no body derived classes must implement it. Abstract class means you cannot do new on it. And sealed means no further inheritance, or in the method form, no further overriding.
That's the whole picture.
Wait, so here's something I'm curious about. All of this enforcing behavior, making sure derived classes fulfill a contract, it kind of makes the compiler into a compliance system. It checks every class against the abstract contract and rejects the ones that haven't met the requirements. You could imagine that at a much larger scale, like a system where every node in a network has to declare what it implements before it's allowed to operate, and a central authority rejects anything that doesn't fulfill the contract. Every connected device proving its implementation at registration time.
I'm going to pretend I didn't hear most of that.
I just mean it's a compelling enforcement model for teaching academically.
Let's add one more thing. Let's verify that manager pays correctly.
Diana gets, let me think, 96,000 divided by 12 is 8,000 plus the 2,000 bonus, so 10,000. $10,000, and base.calculatePay did the division without me duplicating that code.
Which is the whole point of inheriting from salaried employee in the first place. You get to stand on the work that was already done.
Okay, I want to go back to something. Earlier with the animals, when I wrote animal dog equals new dog and called sound and it used dog s version, you said both sides need to declare intent, but that was after we fixed it. Before the fix, when I had it typed as animal and it called the wrong version, is that going to matter in real code?
That's the setup for something we'll go deeper on in a couple videos. There's a feature called polymorphism that makes that pattern extremely powerful. For now, just know that override is what makes the derived version run. If you had used hiding instead, the base version would have run. The distinction matters a lot when you're holding a mix of animal types in one place and calling the same method on all of them.
And we have a list of animals, all different types, calling sound on each one.
Gets you the right sound for each because of override. Without it, you get nothing for everything.
That's actually a really strong motivation for getting the override right even now, before we see all of what it does.
Now you know what these 4 keywords do and when to reach for each one. Virtual, when you want to allow customization. Abstract, when you want to require it. Sealed, when you want to prevent it entirely. And override is the derived class's side of the contract, the thing that makes the replacement real.
The compiler is the one enforcing all of this, which is a lot better than finding out from a pay stub.
Significantly better. Build a shape hierarchy, an abstract shape with an abstract area method and a virtual describe method, a circle that overrides both, a sealed square that only implements area and lets the base handle the description. Wire them all up, call describe on each, and see which version runs and why. Then try extending square and see what the compiler says. You'll feel the whole thing click into place. Don't just watch it. Do it.